We're going to look at 5 different examples of factorising an expression fully, either into a single bracket or into double brackets. First of those is going to be the expression x squared plus 10x. You'll notice all of these expressions are quadratics as well. So the first one is x squared plus 10x. If we are looking at factorising this, the first question we need to ask ourselves is whether this is going to be into one bracket or into 2 brackets. Now, in this case here, the guide is that there is no constant at the end. We have only got an x squared term and an x term. If there is no constant at the end, that means we cannot factorise it into double brackets. So this here would be factorised into one bracket. That's all we could do. If we're factorising this into one bracket, we need to think about the factors of both of these terms. So what number divides into both of the coefficients, 1 and 10? Well, the only factor is 1, so we don't need to include anything at the front. The other factor, so the other thing that goes into x squared and x would be x. So here we can factorise x out of the bracket. What I would then do is use our understanding of expanding a bracket to help us fill in what would go inside the bracket. So x times by what would give us x squared? Well, that must be x. And x times by what would give us 10x? That would be 10. And that would be positive 10. So I'm going to add 10 in that bracket. So that's our first one. For the second one, we've got 2x squared take away 16x. There's still no constant at the end. So this could still only be factorised into one bracket. So let's look again at the terms. We can factorise a 2 out of both of these because 2 is the biggest factor of 2 and 16. So I'm going to write 2 at the front. Let's look at the letters. So we've got x squared and x. So x is also a factor of those two as well. Now 2x times by something gives us 2x squared. That must be x. And 2x times by something will give us negative 16x here. We can treat that as. So that there would need to be negative 8 to give us what we've got here. Okay. For the next one, we've got 3xy plus 12x squared. Here we have got 2 variables. We've got an x and we've got a y. We've also got an x squared term here. We haven't got a constant. We cannot factorise into 2 brackets. This is still only one bracket. Let's look at what is a factor of both of these 2 terms. So 3 is the biggest factor of 3, and 3 would also go into 12. So 3 is the biggest factor of 3 and 12. Let's have a look at the letters. Have we got anything to do with y in both? We've got y in this term, but we haven't got y in this term, so we cannot factorise y outside. We've got an x term and an x squared term. X divides into both of these, so we can take x out. We can't take x squared out because there is not an x squared term or higher in here, only an x term. So if we've done that, let's work out what goes inside. 3x times by what gives us 3xy, that would be y. 3x times by what is going to give us 12x squared. So we need to times the 3 by 4 to get 12. And we would need to times the x by another x to give us x squared. So that term there will be 4x. And it would need to be positive 4x to give us the positive term here. Okay, so for those 3 we factorise into a single bracket. For this fourth one, we have got a constant at the end. We've got a constant of 5. So this tells us, well, when we're looking at this, we can't see that there's actually anything that we could factorise out of this if we were just looking at factorising this into one bracket. This is because this should be factorised into double brackets. And we can use a method here that works for any quadratic when the coefficient of x squared is 1. In this case here, to decide on what goes into our brackets, we can use a bit of a rule that helps us. Now, firstly, these 2 terms here must times together to give x squared. And the only way of doing that is by timesing x by x. So we know that much. Now, to work out what goes in the second 2 parts of the bracket, we know that these 2 numbers must multiply together to give positive 5, and they must add together to give positive 6. So they're going to add together to give that, and they're going to times together to give that. And we can decide on what the two pairs of numbers would be. The best way to do this is to think about the factors of 5. So what numbers times together to give 5? Actually, there are only two factors, 5 and 1. So it's going to be 5 and 1. Let's just check, do they add together to give positive 6? Yes, they do, so that works. Now, it doesn't matter which way round we include 5 and 1, because as we know, when finding the product of two numbers, it doesn't matter which order they're in, it will still give us the same answer at the end of this. So that will be our answer there for factorising the fourth one into double brackets. For the final one, we've got a similar question because we've got a constant. So this is also going to be factorised into double brackets. And we're looking for two numbers that times together to give 8. And they're going to add together to give positive 6. In this case here, let's think of the factors of 8. It could be 8 and 1. It could be 4 and 2. So there's two pairs of factors there. 8 and 1, 4 and 2. Which of those two add together to give 6? Well, that must be these two. So 4 and 2 will be the numbers that will go in our bracket. So let's put in x plus 2 and x plus 4. Remember, these two can be the other way around. It doesn't matter which way around we put those in. So we've looked at 5 examples where we can either be asked to factorise into a single bracket or into double brackets. And these are all quadratic equations.